We had just finished finding the missing measures in parallelograms. Now we are going to work on proving if quadrilaterals are parallelograms given the vertices of a polygon. There are 3 methods to do this. This video will review method 1. For method 1, we want to show that both pairs of opposite sides of a potential parallelogram are congruent given the vertices on a coordinate plane. We can use these ordered pairs to calculate the distance between the vertices by the distance formula. If we get the same distance for the pairs of opposite sides, then they are congruent. To summarize, we want to see for each parallelogram if the top is congruent to the bottom and the left is congruent to the right. So we are going to use the distance formula. Just a reminder, this is the distance formula right onto the right here. We're going to use that to find the distance of each side. So for example 1, most of the time the vertices are going to be drawn in a clockwise position starting with the top right corner. However, you want to double check. So I drew a rough sketch, and it doesn't have to be exact. I just drew a rough sketch of how the points would be ordered between which one's more on the top, which one's more on the right, which one's more above or below each other, so that you can see what points make up the top and bottom. So by drawing this sketch, we can see that line segment AB is going to represent the top of our parallelogram. So we're going to first find the distance between AB. So x2 minus x1 will be 3 minus negative 4, which turns into a plus. And then y2 minus y1 is 4 minus 2. Simplifying, we get that line segment AB is the square root of 53. Now we're going to check the bottom to see if we get the same. So the bottom of our parallelogram would be line segment CD. So now we're looking at these 2 points. So x2 minus x1 will be negative 2 minus 5. y2 minus y1 will be negative 1 minus 1. Simplifying, we see that we get the same thing. So that means that line segment AB is congruent to line segment CD. Now we're going to look at the left and right. So the left side of our parallelogram will be line segment AD. So x2 minus x1 will be negative 2 minus negative 4. y2 minus y1 will be negative 1 minus 2. Simplifying, we get that the left side is the square root of 13. Now we want to show the right side. So the right side of our parallelogram will be points B and C. x2 minus x1 will be 5 minus 3. y2 minus y1 will be 1 minus 4. Simplifying, we see that line segment BC is also the square root of 13. So that means that the left and the right are congruent. So that shows that parallelogram, or the quadrilateral ABCD, is a parallelogram. All right. Example 2, we want to show if parallelogram PQRS is, well, we want to show if this quadrilateral is a parallelogram or not. doing a rough sketch, we can see that PQ make up the top, RS make up the bottom, PS makes the left, and QR makes the right. So we will start with the top. X2 minus X1 will be 4 minus negative 4. That'll turn into a plus. Y2 minus Y1 will be 6 minus 4. Simplifying, we get the square root of 68, which can be simplified a little bit. That'd be 4 times 17, so that's the same as 2 root 17. All right, now we want to see if the bottom is that same distance. So we can see by our sketch that the bottom would be RS. So we're looking at these two ordered pairs. X2 minus X1 is going to be negative 2 minus 5. Y2 minus Y1 will be 1 minus 2. Simplifying, we get that it's the square root of 50, which we can simplify a little bit. That's 25 times 2, or 5 root 2. All right, so we got that the top is 2 root 17 for the distance, and the bottom is 5 root 2 as a distance. So already we can see that the top and the bottom of our parallelogram, or our quadrilateral, is not the same. So if the top and bottom are not congruent, then this cannot be a parallelogram, regardless of the left and right. So we have a little bit of a shortcut. If the top and bottom are already not congruent, we can go ahead and stop, because we know that both sides have to be congruent. So this will not be a parallelogram. So just to recap, for example 1, we showed that the top and the bottom, or line segment AB and CD, were congruent. They both equaled the square root of 53. The left and right, they both equaled the square root of 13. So that told us that the left and right were congruent. And since both pairs of opposite sides are congruent, that makes ABCD a parallelogram. However, when we got to example 2, the top measured 2 root 17, the bottom measured 5 root 2. Because the top and bottom weren't congruent, it doesn't matter if the left and right are congruent or not. Both pairs of opposite sides are not congruent, so PQRS is not a parallelogram.